In this video, we're going to be talking about input-output relationships or function rules. So our goal is to be able to use and create those function rules. And specifically, in this video, we're going to focus on the using part. So here's our first function, y equals 2x to the second power. So we should be able to take this rule, y equals 2x squared, and find all of the input-output pairs that this rule represents. So in other words, I could put any x value in I want, and I should get out a y value. I should be able to take those input-output pairs, create a table, create a graph, and identify some key features. So the table they want us to fill in gives us these x values, gives us these inputs. Now the domain for this function is all real numbers. So I can put any x value I want in, but specifically they asked me for -2 through 2. So those x's need to be substituted into our function where the other x is. So we're going to do one first, right? So I'm going to put -2. I'm going to substitute it in that x spot. So we have y equals 2 times -2 to the second power. Now this we're just simplifying with order of operations. So -2 squared is 4. 4 times 2 is 8. So when I put a -2 in, I get an 8 out. I can take that point, -2, 8, and plot it on our graph. We're going to do the same thing for -1. Put -1 in that x spot. I simplify, -1 squared is 1, times 2 is 2. I put 2 in, I put -1 in, I get a 2 out. I can plot that point, -1, 2. So this rule is showing me all of the possible combinations, essentially, for inputs and outputs. I'm organizing it in a table, and then I'm plotting that on a coordinate plane. Now we could also put in things like 0.75 or fractions, but we're going to stick with these integers, right? We're going to do one more, put 0 in, y equals 2 times 0 squared, 0 squared is 0, 0 times 2 is still 0. I plot the point, 0, 0. We're going to do the same thing for these other ones. These are the inputs and the outputs. We plot these points, and then we can connect these points. And that's what our graph would look like. So some key features we can talk about with this function to identify maybe some relationships. The y-intercept is 0, 0, because that's the point on the y-axis when x is always 0. You can always find your y-intercept by substituting 0 in for x. The x-intercept is that same point because that's the only point on the x-axis. You can always find your x-intercept by substituting 0 for y in your function rule. And the rate of change is not constant. You can tell because our graph is curved, right? And if I look at my table, from 8 to 2, I went down 6, but from 2 to 0, I only went down 2, despite going up by a constant amount in the x's. So our rate of change is not constant. So this graph now represents all of the xy pairs for our input, right? Even though this point right here that my cursor is on is not in my table, that's still an input-output pair that if I took and substituted into my rule, I would get a true statement, okay? So let's look at another example. Now we have the function y equals -2x plus 9. This time, they didn't give me any numbers in our table, but we can put any x value we want in. So I'm just going to choose some. You can choose whatever you want. I'm just going to pick 0, 1, 2, 3, 4. Okay, you could pick anything because they didn't give us a value to choose. So those inputs go in that x spot. So again, I have all of my equations ready. This is where I'm going to put in my values. So those numbers go in there. And then I'm going to simplify them. Now order of operations tells me I have to do multiplication first. So -2 times 0 is 0, 0 plus 9 is 9, right? We do that for all of them. And we end up with these values. Those are the outputs. So when I put 0, 1, 2, 3, and 4 into my function rule, I got out 9, 7, 5, 3, and 1. Those would be the outputs. Now we can take this graph, or these points in our table and plot them on our graph. So 0, 9 plots up there, 1, 7, 2, 5, 3, 3, 4, 1. If we connect that, we end up with this line, okay? So every single point on this line, even the ones that don't have polka dots next to them, this point and this point and this point are all input-output pairs that if I substitute them into my rule would make my equation true. So I could ask you things like, hey, is the point 5 negative 7 on the graph. Okay, well I can look at this and see 5, negative 7 is right there, so clearly it's not on my line. But I could use my rule to figure that out, because if 5, negative 7 is on our line, that means when I put a 5 in the x spot, I should get out a 7 in the y. And I know that's not true, right? Negative 2 times 5 is negative 10. Negative 10 plus 9 is negative 1, not negative 7. So that's another way we can use these input-output rules. So key features, our y-intercept is 0, 9. Remember, the input of every y-intercept is 0. Our x-intercept, according to my graph, is 4.5, comma 0. Remember, an x-intercept always has an output, a y value of 0. And in this one, our rate of change is constant. You can tell because every time to go from point to point, we go down 2 to the right 1, down 2 to the right 1. We have even perfect steps. My line is straight. That's how I know my rate of change is constant. You can also see that in the table. Minus 2, minus 2, minus 2, minus 2, plus 1, plus 1, plus 1, plus 1. All right, one last example. In this one, we have y equals 1/2 x minus 5. And in this table, they gave us an output of negative 3. So it's in the y spot. That's important because that means I'm going to put that negative 3 in the y location, and we're going to solve. So negative 3 equals 1/2 x minus 5. Well, now this is an equation that we're solving for x. So I add 5 on both sides. That's 0. So I have 1/2 x equals 2. Now to undo that 1/2, I can multiply by 2. So 1/2 times 2 is 1. That cancels, and I get 4. So when I have an output of negative 3, I have an input of 4. For these, you can pick anything you want now. You can fill in the rest of the table. I just picked these values. Put a negative 4 in, I get a negative 7 out. So I just picked some other ones, put them all in the x spot, simplified them just like we did previously, and these are the values we got. If I take these values and I plot them, we end up creating this line. So our key features, things to talk about, y-intercept is 0, negative 5. The x-intercept is 10, 0. And our rate of change is constant. The domain for this, the inputs, can be anything we want. So that is how we use function rules.